Hi class, how are you today? What is that expression on your face supposed to mean? The learning target for today is to be able to add and subtract rational expressions. For the scale, you're a 3 if you can add and subtract rational expressions. You're a 2 if you can add and subtract rational expressions with monomial denominators. You're a 1 if you can add and subtract rational expressions with equal denominators. And you're a 0 if you can not add or subtract any rational expressions. Let's get started. All right, so now we're going to learn about adding and subtracting rational expressions. We've been simplifying them. We've multiplied and divided them. Now we're going to add and subtract them. So when you add and subtract rational expressions, just like any other fractions, you need common denominators. So to get common denominators, you have to figure out what you need to multiply the denominators by to make them the same. So on this first one, we need to make 5y and 2 the same. So we need to multiply 5y by something and 2 by something else to get them to equal the same thing. Well, in this case, if we multiply 5y by 2, we'll get 10y. And if we multiply 2 by 5y, we'll get 10y. So that's what we're going to do. So we multiply 5y by 2. And what we do to the bottom of the fraction, we also have to do to the top. And then we do the same thing on the other fraction, but instead we multiply by 5y. And 2 times 4x is 8x over 2 times 5y is 10y plus 3y times 5y is 15y squared, and 2 times 5y is 10y. So now we can make this a singular fraction. On top we have 8x plus 15y squared, and on the bottom we have 10y. Remember, the reason we get common denominators is because the denominator of our answer is also going to be that common denominator. So we don't add the denominators, we keep it the same. And 8x and 15y squared cannot be combined in any way, so that's as simple as we can get this. On this next one, we have binomials, but it's still going to be the same thing. Now, we have 2x plus 5 and x plus 4. But you can't factor anything out. If you could factor something out, that would make it so you have less things to multiply. But in this case, we have nothing to factor out, so we're just going to multiply the left by x plus 4 and top and bottom. And make sure you're multiplying everything, so throw some parentheses around that to show that we're multiplying the whole thing. And the right by 2x plus 5. And again, parentheses to make sure we're multiplying everything. So 4x times x plus 4, that'll give us 4x squared plus 16x over x plus 4 times 2x plus 5. And then minus 10x plus 25 all over x plus 4 times 2x plus 5. Now we can combine those. So 4x squared stays there. 16x minus 10x is positive 6x. Don't forget that this minus goes to everything. So we subtracted the 10x to get 6x, and then minus 25 as well. And then in the denominator, we still have x plus 4 times 2x plus 5. And now we can try to factor the top, and if we could factor it, we could cancel some stuff out at the end. However, in this case, this is not factorable. The top is not factorable, so we can leave this like this. Now, technically, usually we say the bottom is not fully simplified because there are multiples there. We've got the factors, and so we could multiply those out. So the top would stay 4x squared plus 6x minus 25, and then the bottom would end up being 2x squared plus 5x plus 8x plus 20, which would then simplify down to 2x squared plus 13x plus 20, with the numerator staying the same. And so I will accept either of these as an answer, just because keeping it in factored form is often useful when simplifying stuff down, but in this case, I will accept either answer. All right, and now time for the sponge activity. I want you to simplify by adding and subtracting the rational expressions. Number 1, 2x over 3 plus 5x over 4x. And number 2, 3 over x plus 5 minus x minus 1 over 5x minus 4. That's it for this lesson. Once again, please make sure to take notes on the entire lesson, take a picture of everything, submit it all to Doodle Classroom, and have a good night.